We will continue the course for 608 EPA 608 Universal Certificate. Now we will continue. We finish refrigerants the last time. We'll continue now refrigerant blends. We'll start with this one. Purpose of refrigerant blends.
In this module, we will introduce refrigerant blends and discuss how to use them in HVAC practices.
As we discussed in the previous module, refrigerants used in the past were found to be harmful to humans and the environment. These refrigerants were phased out in the US and internationally. After being phased out, CFC and HCFC refrigerants could no longer be used. So, what happened to the equipment that operated on those refrigerants? It is for this reason that refrigerant blends were created. Before CFCs and HCFCs were fully phased out, the industry developed refrigerant blends. These refrigerant blends were developed to match the properties of the phased-out refrigerants. Refrigerant blends contain a mixture of two or more refrigerants. Generally, a refrigerant blend will contain two refrigerants. If it contains three refrigerants, the term for that is a ternary blend. For example, our 407C is a ternary blend of three HFC refrigerants. It contains 23% R32, 25% R125, and 52% R134. Refrigerant blends are standardized by manufacturers and have their own ASHRAE numbers. Our 407C, for example, is a unique ASHRAE number.
Refrigerant blends take on the ASHRAE number of the main refrigerant in the blend. True. False. Okay. Take ASHRAE. Take both. Refrigerant blends have their own ASHRAE number. These numbers are different from the ASHRAE numbers of the refrigerant makeup of blend. Okay, this is different, totally different. What is the ternary blend? The three refrigerant blend combined, three refrigerant blend together, three replacement refrigerant, none of the above. Three refrigerants blend together. Yeah, correct.
Refrigerant blends are manufactured by companies like Honeywell or DuPont. Blends are made to have specific properties in specific ratios. Otherwise, they won't work in an HVAC system. Technicians cannot mix their own refrigerants. Mixing your own refrigerant is illegal and punishable by heavy fines. One of the risks of technicians mixing refrigerants is that the resulting refrigerant may be a mixture with unknown quantities. Such a mixture can no longer be used in equipment. This is because the mix will have different properties than what the equipment was originally designed for. Mixing your own refrigerants would be the same as mixing your own gasoline to put into your car. It would be extremely difficult to do that because your car is a complex machine that runs on a specific blend of chemicals. HVAC systems are the same way. If the technician mixes their own refrigerants, it could create unpredictable temperature changes and place stress on the equipment. All of this can cause equipment to fail and not work properly. Putting this mix into an HVAC system will also void the warranty of the equipment. This is because it goes against the manufacturer's guidelines for use. These reasons are why technicians should never mix their own refrigerants. If a technician accidentally mixes their own refrigerants and sends the mixture to be reclaimed, the reclaimer may refuse to accept it or destroy the refrigerant at the owner's expense. It is very expensive to destroy refrigerant.
The technician can make their own EPA approved refrigerant blends. False. Which of the following are reasons to not to mix your own refrigerant? It is illegal. It can cause equipment failure. Sorry. The resulting mixing has an predictable temperature. All of above.
In this module, we discussed how refrigerant blends are developed and their different properties.
We will continue. The next one is types of refrigerant blends.
In this module, we will dive deeper into the different types of refrigerant blends and discuss how they are used in HVAC practices.
Depending on the refrigerants involved, refrigerant blends can have different properties. Let's take a look at a video that gives you a brief overview of this.
In the following minutes, we will discuss zeotropic and azeotropic refrigerant blends, plus the definition of glide and fractionation. Zeotropic blends are a mixture of two or more components. The components of this refrigerant have different boiling or bubble points. An example of a zeotropic blend is any 400 series refrigerant, such as R407C, which is a blend of R32, R125, and R134A. An azeotropic refrigerant is a mixture of two or more components that boil at the same temperature. The components in this type of refrigerant will evaporate and condense together as one. An example of an azeotropic refrigerant is R502, which is a blend of R22 and R115. In this case, there is no refrigerant glide to worry about. But you may ask, what is refrigerant glide? Glide is the difference between the boiling point of the most volatile component compared to the least volatile component within the refrigerant blend. For example, R407C at 40 psig has a dew point, that's the point of condensation, of 21.94 degrees Fahrenheit, and a bubble point, the point of evaporation, of 10.44 degrees Fahrenheit. This means that this particular zeotropic blend has approximately 11.5 degrees Fahrenheit of glide. In this connection, there is one additional point to consider, and that is fractionation. Let's continue using R407C, and let's say the bottle is stored at room temperature. Each component of this refrigerant blend will boil off at different temperatures separating from the liquid mixture. The vapor of each refrigerant would occupy its own space above the liquid. This is known as fractionation. Because these components have differing properties, there may be more of one gas at the top of the refrigerant bottle than the other. That is why it is important to charge this type of refrigerant as a liquid to ensure the system receives the full blend. It is recommended, however, that this type of refrigerant is flashed into the system to avoid the possibility of liquid entering the compressor, damaging that compressor.
As mentioned in the video, there are two different types of refrigerant blends, zeotropic blends and azeotropic blends. Zeotropic blends are mixtures of two or more refrigerants that have different boiling points. Remember, the boiling point of a substance is the temperature at which it changes from liquid to gas. This means that in a zeotropic blend, the components boil and condense at different temperatures. The different refrigerants in the blend react differently from each other. Think of a boiling pot of water that's been mixed with oil. While the water is boiling and turning into water vapor, the oil remains in liquid form. This is akin to what happens in a zeotropic blend. R407C is an example of a zeotropic blend that we commonly see. In general, all refrigerants with an ASHRAE number of 400 are considered zeotropic. R407C is a blend of all HFC refrigerants including R32, R125 and R134A. Azeotropic blends are a mixture of two or more refrigerants that have the same boiling point. These refrigerants boil and condense at the same temperature. In an azeotropic blend, the refrigerants will act like a single refrigerant. R502 is an example of an azeotropic blend that we commonly see. R502 is a blend of R22, HCFC, and R115, CFC.
R07 is an azeotropic blend. Yeah, this one, I think. Oh no. Zeotropic, not as azeotropic. Ah, sorry. Zeotropic. In azeotropic blend, all refrigerants have the same boiling point. True. False. In azeotropic, not the same.
In this module, we discussed how different types of refrigerant blends are developed. In the next module, we'll look at the properties that they have.
Okay, let's look at the properties of refrigerant blends.
In this module, we will discuss various properties of different refrigerant blends.
When it comes to zeotropic blends, it is vital to consider temperature glide. Temperature glide is the difference between the dew point and the bubble point. The dew point is the temperature at which the first refrigerant in a blend turns from vapor to liquid. The dew point is specific to refrigerant blends. This is the same as the temperature of condensation in single refrigerants. For example, in R407C, the first refrigerant condenses at 21.94 degrees Fahrenheit. So the dew point of R407C is 21.94 degrees Fahrenheit. The bubble point is the temperature at which the first refrigerant in a blend starts to turn from liquid to vapor. Like the dew point, the bubble point is specific to refrigerant blends. It's the same as a boiling point in single refrigerants. For example, in the blend R407C, Fahrenheit point of R407C is 10.44 degrees Fahrenheit. As we said, temperature glide is the difference between these 2 points. Since the dew point is 21.94 degrees Fahrenheit and the bubble point is 10.44 degrees Fahrenheit, the temperature glide is the difference, which would be 21.94 degrees Fahrenheit minus 10.44 degrees Fahrenheit, which equals 11.5 degrees Fahrenheit. Therefore, the temperature glide of our 407C would be 11.5 degrees Fahrenheit.
What does the temperature glide mean? The difference between the bubble and the dew point, the difference between the boiling point of R22 and the replacement. on the temperature change in a refrigerant. Not of the above. None of the above. None of the above. Oh, when the temperature. Oh, what is the bubble point mean? The temperature that the first refrigerant in a blend turned to liquid. The temperature that the first refrigerant in blends turned to vapor. Yeah. What is the dew point? Temperature at which at last the refrigerant in blend turns to liquid. Yeah. Oh, sorry. Temperature which is the first refrigerant in the blend turns to liquid.
In an earlier module, we
The
learned that
first
the
blend,
act
not
of
the
adding
last.
refrigerant into a system is called charging. Despite the name, it is less like charging your phone and more like filling up your gas tank. Blended refrigerants need to be charged as a liquid. This is to ensure that the different refrigerants in the blend spread out evenly and equally through the system. In vapor form, refrigerant blends are more likely to separate via a process we call separation fractionation. Fractionation occurs when the refrigerants in a blend settle into different layers. Think of a glass containing oil, water, and sand. If you leave the mixture, it will settle into 3 layers. If you attempt to pour out some of the mixture, it will mostly be the first layer that is poured out. The same thing happens with vaporized refrigerant blends. If you charge a system using a refrigerant blend that is in vapor form, you will not get the full blend. You will only get the top layer of the mixture. This is why it is important to charge blends as a liquid. Fractionation is a problem particularly with the refrigerant blend R407C. This is because R407C is a zeotropic blend. As we discussed earlier, a zeotropic blend contains refrigerants that boil separately.
Which of the following statement is true about fractionation? Select all that apply. Okay, it occurs when refrigerant settle into layers. Okay. Yeah, I think. No? It happen in vapor, it happen liquid state. Option A and B are correct. Okay, a process where plant refrigerant settle into layers. Cure refrigerant in vapor. Refrigerant blends
When a
need to be
system that contains
changed as liquid,
refrigerant
yeah.
blends is leaking, the refrigerant will leak at different rates. This is because each of the refrigerants in the blend has a different vapor pressure. Refrigerant blends need to be charged as a liquid to get an even mix of the different refrigerants in the blend. Since these blends can experience fractionation, charging when they're in liquid form ensures that we get the correct ratio of all the components. You can think of this fractionation as orange juice with pulp. The pulp settles down to the bottom of the container when you leave it in the fridge. If you want the pulp to be evenly distributed, you need to shake the container. It is not recommended to shake refrigerant containers because they're pressurized. However, we can charge the system with the refrigerant as a liquid to get the full blend in even proportions. In this module, we discuss the properties of different refrigerant blends.
We will go to the next one, next part of the course, this retrofitting systems. Let's see.
In this module, we will define the term retrofitting and explain how existing refrigeration equipment can be retrofitted to operate on new refrigerant blends.
R407C is a refrigerant blend of three HFC refrigerants, R32, R125, and R134A. R407C was developed in order to replace R22, an HCFC refrigerant. As we discussed before, refrigerant blends were created to replace refrigerants that were phased out, like HCFC. Even though R407C is generally the best replacement for R22, there are limitations. So how can we use the refrigerant blend R407C in an R22 system? The answer is retrofitting. Retrofitting is when we adapt and make changes to equipment so that it can run on a different type of refrigerant. Existing refrigeration equipment can be retrofitted to operate on new refrigerant blends. Refrigerant blends are designed to have the same properties as the phased-out refrigerants they replace. Technicians must follow the guidelines on which refrigerant blends a system can be retrofitted to operate on.
Which of the following is considered retrofitting? An EPA-approved process to make a DIY refrigerant blends, replacing a system that used HCFC refrigerant. Okay, I think this one. Replacing HCFC refrigerant with other refrigerants, modifying component of the system to use a new refrigerant. Yeah,
A drop-in refrigerant is a substitute
modifying
refrigerant that has the same exact properties
a
as
new
the original
component.
refrigerant. No retrofitting is necessary for a drop-in refrigerant. Recall that according to the EPA, there are no drop-in substitute refrigerants for R22. We must retrofit every system using R22 in order to use other refrigerants in those systems. Some of the widely recognized retrofit refrigerants for R22 include R453A, RS44B, R427A, Furane 427A, R438A, Freon MO99, R407C, Freon 407C, R434A, RS45, and R442A, RS50. We cannot top off an R22 system with any other refrigerant without verifying whether it's compatible. Since there are no drop-in substitute refrigerants for R22, the system can only work with R22. If we top it off with an incompatible refrigerant, we're only mixing them up and making both refrigerants impossible to reclaim. Mixed refrigerants also give us unpredictable temperatures, as we discussed before. Using a different refrigerant may also void manufacturer warranties if it operates outside of their guidelines.
There are no retrofit refrigerants for R22. False. If a refrigerant has a drop in replacement, then no retrofit needed. Yeah, there are no direct drop in replacement for R22. I don't know this one. I don't know. Yeah. All systems run on R22 must be retrofitted to operate
In this
on
module, we
other
discuss how to
refrigerants.
retrofit existing refrigeration equipment to operate on new refrigerant blends.
Okay, let's take the quiz. Okay. Which of the following statement fraction fraction of refrigerant is true? Select all to apply. Is when refrigerant settle into layers, happen in vapor phase, happen in liquid phase, happen in solid phase. When about fractionation of refrigerant, when the refrigerant settle in layer and happen when it's vapor phase. What is the temperature glide? Is the difference between the bubble and the dew point, the difference between the boiling point of R22 and replacement when temperature change in refrigerant. Okay, the difference between, I don't remember this one. What is the bubble point? The temperature at which the first refrigeration plane turns to vapor. What is the what is the definition of dew point? That's temperature at which the first refrigeration is in a blend turns to liquid. Yeah. What is ternary bend? Three refrigerant blends combined. Three refrigerant blend together. Which of the following is considered retrofitting? An EPA approved process to make dye refrigerant blends, replacing systems that used HCFC refrigerant, replacing HCFC refrigerant with another refrigerant, modify component of the system to use to a new refrigerant. Yeah, modify the component of the system to use a new refrigerant. Which of the following are reason to not to mix your own refrigerant? Okay, which of the following are reasons to not to mix your own refrigerant? It's illegal, can use equipment failure, resulting mixing has an predictable temperature, all of above. If a refrigerant has a drop-in replacement, then no retrofit is needed. If a refrigerant has a drop-in replacement, no, yeah. And isotropic blends or refrigerant have the same boiling point. False. R407C is isotropic blend. Yeah, I don't remember this one. Refrigerant blends need to be changed as a liquid. Yeah. Refrigerant blends take on the Ashray number of the main refrigerant in blends. No, they take new. Technician can make their own EPA approved refrigerant. No. There are no drop-in replacement for R22 refrigerant. Yeah, must be changed. There are no retrofit refrigerants for R22. False. Let's check. Okay, we answered all the questions. Submit. Our score is 9.33 of 10. This is the only wrong question. This R07, okay, is an azeotropic plant. No, this R407C is azeotropic plant. Okay, okay. The correct answer is false. Okay, تمام. We finished this now. Okay, let's go back to the course. Okay, now we finish um, the refrigerant blends. Okay, we finish purpose of the refrigerant blends and types of refrigerant blends, properties of refrigerant blends, and finally we discussed this retrofitting systems, and we finish with the quiz.